Well, I thought what we could do today is I thought we could have a change from CB radios and Stabilocks and Marconi's 2955, and I thought we could go back to basics and just indulge in the pleasure of you know, switching off the mind and just building up some radios. Well, I've actually got 4 of these kits to have a go at building, but for whatever reason I can only find 3 of them. And the one I thought we could have a go at building today is this this red one. I wonder if that's the model number there. It says HX108-2. I wonder if that is the model number. So at the bottom of the circuit diagram here, we've got this little information tab. So it says a radio will tune between 525 kHz and 1.6 MHz. It's got this 465 kHz, which I'm guessing is going to be the intermediate frequency. And then we've got this measurement here, which says 1.5 millivolts per metre. Now I'm guessing that that's a sensitivity reading, maybe. I'm not exactly sure. Now this type of radio uses a ferrite antenna, a ferrite rod, so it's not like the radios we've played with in the past, like the CB radios, where you can just stick a 50 ohm connector up its bottom and feed a signal into it from a signal generator. I'm guessing that this is some kind of field strength measurement, but I'm not completely sure how that's expressed. But whatever it is, it says we've got 26 dB signal to noise, and then we've got some more dBs here, greater than 20 dB at 9 kHz. The radio works on 3 volts. I can pick that out. 20 milliamps, so I'm guessing 20 milliamps. I wonder if that's the supply current. I'm guessing it is. Again, that seems quite low, 20 milliamps. You can barely light an LED with that. And again, I'm guessing that's audio output power, 180 milliwatts, 10% of something or other. So I'm guessing that's the audio output power, but again, that seems very low, 180 milliwatts. I could understand that for driving an earphone, but this radio does come with a speaker. So as speakers go, this one actually looks like quite a nice one. It's got a proper part number, YD58-1. It's a 0.5 watt speaker, and it's 8 ohm. And as I said, as speakers go, this looks like quite a nice one, in that all the other kit radios have got horrible speakers with plastic diaphragms, and I'm sure that they will sound awful. And this one actually, you know, it's got a nice paper cone on it. It's got a fairly huge magnet on the back, so hopefully this will sound slightly less awful than some of the other radios. But we'll have to suck it and see, won't we? As I said earlier, today I think I just want to switch off and enjoy stuffing some resistors into holes, so I'm not going to get too bogged down into the circuit. So we've got our 3-volt battery here, which is 2 AA cells, and we've got our switch that turns the power on and off, and that switch is also ganged with the volume control pot, which is here. So when we switch the power on, it directly supplies power to the output amplifier stage, and what that consists of, it consists of a driver transistor and then 2 NPN transistors. Now it's quite interesting the way they've actually done this, because they're achieving kind of the push-pull without using like an NPN and a PNP complementary transistor. They've done it a slightly different way. So they are transformer coupling the speaker to it, and what they're doing is they're feeding that center point of the transformer with 3 volts, and then what these transistors are doing, they can pull down each side of that center tap. Now if you pull down one center tap, that will effectively make the voltage rise at say this point here, but if you actually pull the other centre tap, it will effectively make the voltage rise at this side. So it's just a way of kind of producing a plus and minus volt supply there. So I think that's quite clever. You look at the way that these 2 output transistors are biased, and they're actually just using a signal diode here to bias them. So they've got a 1N4, what's that, a 1N4118. So that's just going to be a conventional signal diode, probably with like 0.7 of a volt drop across it. So these transistors are probably on the point of conducting. They may even be slightly conducting already, but that's what that's doing, and it's getting its power from that 1K resistor there. And of course the driver transistor is actually coupled to the output stage, again using another transformer. So we'll just carry on following the power. And you see we've got an R12 resistor here, which is 220 ohms. So what that's actually doing, that's quite interesting. If you follow the power along, we've got these 2 diodes here. And what these are a diode clamp. because this is the RF circuit here, and it's got things in it like our local oscillator, effectively it's a VFO. And the problem with local oscillators is that they're extremely sensitive to variations in voltage. So what you can actually get is, if you've got your speaker playing a big dum 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 bass sound, you'll actually find that because of the internal resistance of the batteries, you would find that what would typically happen is your supply voltage to the whole radio will slightly be going up and down. Now that doesn't matter for the power amplifier output stage, it won't make any difference. But if the voltage is varying, especially around the local oscillator here, what will actually happen is the local oscillator will respond to that by changing frequency, and it just won't work very well. So what somebody's done here, they've put just two diodes in series with each other. So the first diode is going to conduct about 0.7 volts, the second diode is going to conduct about 0.7. So you add both of them together, and it's going to clamp the voltage at I don't know, probably about 1.4 volts here. So all the RF circuit is fed with a constant 1.4 volts, which in some ways is a little bit wasteful, because we've got our 3 volts coming from our battery here, and then we're effectively clamping it to about half that. But I guess that what that also means is the radio is going to keep running until the batteries have really run down to quite a low level. So that's a nice little feature, this little this diode clamp. It's just a very simple regulator. And we've got our ferrite rod antenna, which is labelled up B1 here, and you can see that the ferrite rod antenna, it's got two capacitors shown across it. So one of these capacitors, I don't know if you can see the arrow, the one with the arrow on it is going to be the main tuning capacitor, and then it's got a second little capacitor drawn across there, and it almost looks like a T shape on the end of the variable capacitor symbol. So what that is, that's a trimmer capacitor for I don't know if you say it's for padding, but basically it allows you to have just a fine adjustment over C1. So C1 is the main tuning capacitor, and that's variable when you twist the knob on the radio, whereas this trimming capacitor is fixed. So the output from our ferrite rod antenna, that's coupled into the base of transistor V1 here. And you can just see, if you follow the emitter down, we've got some other RF goodness going on here. So it's going into one of our tuning cans, and you can also see there we've got a coil of wire there, and we've also got some capacitance here. But what that actually is, that's an oscillator circuit, and what's going to be happening is that this is going to generate, well, it's going to generate out what is our local oscillator. And again, you can see that it's got another capacitor there, C1 again. So again, that's our main tuning capacitor. And then it's got a bar across it. Again, we've got another trimmer next to it. So the idea of a super radio is, of course, as you increase the frequency of the station that you want to listen to, it'll actually increase the frequency of the local oscillator, so that we keep the same down conversion of 465 kilohertz. So that's what that's doing here. So we're going to get out of this tuning can, which is labelled, is that B2? So out of B2 we're going to get our IF frequency of 465 kilohertz. So after these two stages of amplification and kind of bandpass filtering, finally it dumps out the IF signal, it dumps it out to here. And again, something else quite interesting. Now the normal thing you would find here is just a single diode. I mean, in an old radio you'd have found a germanium diode, but they're not using a germanium diode. What they're actually doing is they're actually using a base emitter junction in a transistor to act as their demodulation diode. I think that's kind of interesting. I suspect the reason that they've done that is just to save money, because it looks like a lot of these transistors, they've got it labelled up as 9018H. Maybe it was just easy for them to buy a number of these transistors as opposed to just buying a dedicated detection diode. Maybe that was easier for them. So we get our demodulated signal, and that's going to come out of the emitter of the resistor here. That's going down, and we've effectively got these this low pass filter here, which is just smoothing out the high frequency component of the IF, and that's just going to leave us with a nice audio envelope then. So our smoothed audio output is being developed across this potentiometer here, which is a volume control pot, and you can see that the centre point, our wiper connection there, that's being capacitively coupled to our driver transistor here, which is V5, and effectively now we're back where we started. So let's have a close look now at our bag of bits. because we all like a bag of bits, don't we? Oh god, everything just flew everywhere then. So we've got a little red lanyard strap. Got a great big thumb wheel here, which I'm guessing is the tuning adjustment for the variable capacitor. Got an unknown piece of plastic. Got a piece of wire. Got some yellow wires, lots of pieces of wires, yellow, black wire. We've got some kind of I'm guessing that's a battery terminal clip of some description. Oh, I've got some diodes here, so there must be our 1N148 diodes. How many of them have we got? Should have 2 of them. Oh, seem to have an extra one, must be an extra diode hanging about somewhere. So this thing here is a very delicate looking tuning coil that slips over our RF antenna. In fact, is the RF antenna in there? Let's just find that. So the antenna just consists of this ferrite rod, and this tuning coil will slip over it like that, and maybe when we've got it set up and tuned, we'll be able to have that fun of melting candle wax all over it like they used to do back in the day. So we've got these 2 little transformers here, and not sure which way around they go. This one has maybe got Y written against it, so maybe that means it's yellow. Not sure, we'll have to look at that in a bit. The driver stage to the output power amplifier stage is also transformer coupled, so maybe that's that green one. Not exactly sure, we'll have to play with that and figure them out in a bit. Quite a horrible piece of paper with a pointer stuck on it. And like all simple radios like this, it comes with this very nice and useful variable tuning capacitor. It's been years since I've played with one of these. I'm sure, oh, that's quite stiff actually, that. Oh, that feels horrible. In fact, does it move at all? Oh, that's got to be one of the most horrible feeling variable capacitors. Actually, the touch as you turn it, not only is it very stiff, it kind of makes a horrible creaking noise as well. Now, this type of variable tuning capacitor takes me right back to my childhood, because I can remember having spent many happy hours. You know, you get an old bog roll and you take the cardboard centre out of it, and you wrap a few turns of single core wire out of it that you've robbed from somewhere. You get your crystal earpiece and build your coil and get your germanium diode and hook one end up to the earth, which was a radiator, and then a random length of wire. Now, I still today think that crystal radios are absolutely magical. It almost feels like you're getting something for nothing. Shame there's not really anything on AM worth listening to anymore. So the first resistor we're going to install is R1, and to actually install that you've got to bend it over because it has 2 holes which are next to each other, so the resistor stands vertically. So you can see if we take our resistor and bend it into a hairpin shape, there's the 2 component legs. Now, one of the component legs is going to be very long because that's going to be bent over, and the other leg is just going to drop into the hole in the board and be a very short leg. Now, what you actually want to do is you want to figure out, looking at your circuit diagram, what the high impedance side of the circuit is or the low impedance side. So what I mean by that is, for example, one side of this resistor is going to be connected to ground. So the ground is a low impedance side. So what you actually want to do is you want to actually connect this folded leg that wants to go to the ground side or the low impedance side. And the reason you want to do that is because if you've got a high impedance circuit, this whole loop of bent wire here, it's acting like a loop antenna and it's picking up noise. And it's the same with capacitors when you install them in circuits as well. You'll find that they work better one way around as opposed to the other. So take a little bit of time when you're installing it to figure out which is the high impedance side of your circuit and the low impedance side. So just to explain that again, so the loop of wire, I'm going to put that to the supply rail because that's low impedance, and the straight section of wire is going to go to the high impedance side. So if you've got a choice, always put the loop of wire to a power supply rail. So the orientation of our resistor R1 is going to be like this. So the low impedance side is on the left and the high impedance side is on the right. So again, when I'm installing a resistor, I tend to solder one leg down first, and then I turn the board back over and adjust it until I'm absolutely happy with it, which I am there, and then I'm just going to go ahead and solder the other leg in. And one thing I have noticed already, these even though I've cleaned this circuit board, it's not taking solder as easily as you know, it perhaps could do. So you might actually choose to put a bit of additional flux on it. You might choose to do that. So that's our first resistor installed, so we can go ahead and put a little cross in the box there. What I'm going to do now is I'm going to go ahead and I'm just going to install all these resistors. I'm going to do that off camera because, well, that's going to be even boring than the rest of my video. So this is what our circuit board looks like with all our resistors installed, and they do all stick up apart from this one resistor here, which is R12. That one does go flat, but all the others are stuck up in the air. And of course I know that some people aren't happy unless they're moaning about something, so here's a close look at my soldering so you can get annoyed about it and leave it in the comments. So just looking at what's next on our little parts list, we've got to install diode 1, diode 2 and diode 3. So there's diodes 1 and 2, which are just making up this very simple voltage clamp, which is going to effectively just regulate the voltage to the RF side of the radio and keep the oscillator on frequency. And we've also got, I saw another diode somewhere, where's D3? There's D3, okay, and D3 is going to be used to just put some bias on the centre point of our push-pull amplifier there. So I've just noticed these diodes also have to be stood up on their end, and we do have to get these the right way around, so that looks like that's going to be D3. Here's our D1, and finally our D2 goes there. There we go, we've got all our diodes installed, so there's D1, there's D2 and there's D3 up the bottom there. So I wonder what W is it on the circuit diagram? Turns out that item W is the variable potentiometer for the volume control, and it also contains a little on and off switch, and you can just see in there, you can see the little off and off movement there, and you can see the little spring that gives it its little kind of click, and the little cam that activates it, the little orange thing above it, so that's quite cute, isn't it? Just noticed something that's causing me a little bit of confusion. We do appear to have two C2, so it goes C1, C2, C2 and C4. So I'm guessing that's just a misprint there. So I'm guessing the next one to do is C3. And C3 we're looking for a 10 nanofarad, aren't we? So again, it's got the number on 103. Now of course it's no big deal at all, but some of the lettering on these capacitors is pretty smudged, and that's hard to read, but that is 103. Let's just check it on the LCR meter, and 9.1 nanofarad. So after the massive excitement there of C2 stroke imposter C3 capacitor, what I'm going to do is I'm going to go ahead and I'm going to install the rest of ceramics, and I'll bring you back when I've done that. Now I've just brought you back because the next two capacitors that I was going to install are two electrolytics, which are 4.7 microfarad, and it turns out that these actually are measuring a little bit low, in that they're coming in at, I think one comes in at 3.5 and the other one comes in at 3.4. Now you are allowed quite a wide variance on electrolytics, but I suspect they are just out of tolerance. But again, I had a look in the junk box and unfortunately I don't have any, so I'm going to have to use them. That's what I've got. So there we go, we've got all our ceramic and our electrolytic capacitors installed there. And again, none of them were particularly close to the tolerance. I'm going to use them, that's what's come with the kit, that's what I'm going to use. So I'm continuing to work my way through the installation procedure, and the first thing I've come to is B1. So having a look at the diagram here, it turns out that B1 is actually our ferrite core. This ferrite core has various wires coming off it, and we've got to install these in the right order. The cores themselves seem to be covered in some of this waxy goo stuff. Yeah, I was going to say it feels more like shellac than wax. Maybe it's wax, I'm not sure. But we've actually got to install these wires into the right sequence on the circuit board. So I think I'm going to look at doing that next. So it looks like the first thing I've got to do is push the ferrite rod into this plastic former here. So let me just push that in there. Just wondering whether or not to shorten these wires or not. It's probably not a bad idea to shorten them because you don't particularly want them flapping around in the breeze, I guess. I'm also wondering, do we need to strip the enamel off, or will I just be able to solder through it? Sometimes you can, sometimes you can't. I think I will cut the wires down, just double check I've got the right one. So that comes down there, across, and down to a big hole. So down there, and across to that big hole. So yeah, I think that's correct. So let me just do that. What I think I'll do is I think I'll just turn the temperature up a little bit on my iron, and hopefully it should just melt through the enamel coating on the wire. That's a theory anyway. Okay, there's one done. Now I think there is actually a slight colour difference and a slightly different texture to the wires on this coil, but they're not immediately obvious. It certainly would be easy to get them wrong, and it would actually be easy to wire this up wrong as well. I'm trying to be quite careful here. So let me just trace out where that has to go to. So comes down there and goes to, well, I think it goes to that tab there, doesn't it? Comes down there, goes across there. Yep, that must be it there, must be. And these wires, like I say, they do look and feel a little bit different. Back in the day, you used to get this very fine stranded cable, and I think they used to call it Lintz wire. They used to wire coils of it on very old valve radios and stuff like that. So if ever you've seen something called Lintz wire, this is what it kind of reminds me of. It's got a very fine silk wrapping around it. Yeah, it feels like Lintz wire. All I'm doing is I'm repeatedly tinning it with flux, and usually eventually it will burn through the coating on it. And I've got my soldering iron set quite high. I've got it set to nearly 370 degrees. So I'm just going to put a blob of solder on that pad there just to help identify it and get it ready to accept our wire. I think I'd be very tempted to do something like put caps on over these wires, you know, just to help stop them getting ragged off once you've got the components in. I think I would put some caps on tape over them, or maybe dribble some wax over it, because you don't want these wires shaking about, because they're going to alter the tuning on the radio. So that's the last one. So let's just strip the end of it again. So let's just check them, double check those connections. So it's that one, and that one, and that one. So I'm going to say that's good to go. Now part 31, got no idea what that is. It's got some Chinese writing there. 32 is B2, so what's B2? Oh, there it is. B2 is our first tuning can, isn't it? B2. And it says that's a red one, so where's B2 on here? And I'm not going to bother to actually measure these, I just want to check that the windings are intact. Because it's not unusual for these to be faultily manufactured, and sometimes the wires are broken inside, and once they're in circuit it takes no end of trouble to fault find it. Now, given the lead arrangement on these coils, you can only get them in one way around, because they've got 2 pins on one side and 3 pins on the other. So even I can't get that wrong, but it would be very easy to get them in the wrong place, especially because the instructions for what's what isn't very clear. And I'm still going to double check them, because even when I've installed these in the past, the wires can desolder inside. Right, that's good enough for me. Now, I don't know if this will come out on camera, but you can see that they've got 5 legs, not counting the ones on the can. And each of those legs has got a very thin wire soldered to it. And as I said earlier, it's not uncommon for those wires to come unsoldered or disconnected. And that can cause you a whole world of pain if that actually happens. Well, it feels like we're getting to the end of the build now, so we've just got a couple of these little transformers to install, and I've just gone ahead and I've found a picture of this online so we could work out which one was which, because they are different colours and they have to go in the right place. So that's a yellow one and that's a green one, so they go in those positions on the circuit. And what these are for is that this transformer here, it's got the actual drive, not the output transistors, but the actual drive to the output stage. It's actually transformer coupled to the base of this complementary push-pull amplifier, and then the output from the push-pull amplifier is coupled to the loudspeaker by this yellow little audio transformer there. So let's install them next, and then the only thing left to do is put the transistors in. Now this may already be completely obvious, but I thought it'd be worth mentioning because it might avoid somebody making a mistake. So we've got the audio output transformer here, and hopefully you can see it's got 3 wires on one side and it's got 2 on the other. But if you look at the circuit board, it's actually got 3 holes on one side and 3 holes on the other. So happily this transformer will go in either way around. But if we turn the board over, it is a bit clearer. So you can see that we've got 3 pads on this side which will align with those 3 pins on the transformer, and we've only got 2 pads on this side. The centre pad, well, it isn't a pad, it's just a plain drilled through hole. So our transformer needs to kind of go in that way around, in that orientation. So I'm hoping that that makes sense to everybody. So it's transistor time now, and what's our first transistor? Our first transistor is V1, which is a 901G. So let's see if we can find that fella. So here's our 901G, let's just test that. So it is reading as an NPN silicon transistor with a HFE of 96. So I'm guessing that's working, so that can go installed now, be installed even. And this is where the build instructions should have been a little bit different, because I'm actually having trouble just getting this transistor down here between these components, because it's right down there. Whereas if actually I did install the smaller ones first, if I'd put the transistors in first, then I wouldn't have to try and push down and reach between the coils. So that's a bit of a fail on the instructions. I don't think they've quite got the build sequence correct there. Well, I brought you back where we've just got 2 transistors to go, and I've actually realised I made a mistake early, because I think I said that this was like a complementary pair of an NPN and a PNP transistor that was working in push-pull. Well, I've just had a close look at the circuit and it isn't that. It's actually just 2 NPN transistors. And the reason they can get away with that, if you like, it's because they're using this centre tapped arrangement. So the centre tap of the audio output transformer there, it provides either a positive voltage to the collector here or a positive voltage to the collector on this side. So it's not completely, well, it is a conventional arrangement, but I got it wrong earlier. But one of the things that's interesting, we do have these transistors here which are, you know, one's pushing and one's pulling, if you like, whichever, it doesn't matter which way around you call it. And what I tried to do, or what I am going to try to do, is I found some transistors that appear to have the same batch number on them, because a lot of the transistors had different batch numbers. So I think that's the transistor number there. It's different than stated on the data sheet in that it's a C. What is it now? I can hardly read it. It's a C945 transistor, and they're both C945s, but they've got a number underneath them which is I think that's a G341, and I'm guessing that might actually be a manufacturing date. I'm not sure, but all the other transistors I had the second number was all different on them. So I'm hoping that maybe that's going to give us a little bit of matching between them. The other thing that we could just do is we'll just put them on the meter and we'll just check what the HFE value is for both of them. So our first transistor has got a HFE of 267, so I'm just going to write that up there, 267. And let's check the other one. And that one's slightly higher at 280. Whether that'll make any difference in this circuit, doubt it. I don't think this thing is actually going to be exactly high class audio. I think it's just going to be like a rumbling static box of annoyance. Oh god, well the controls on this feel truly horrible. Now if you look at the instructions that come with this radio, you can see that there's some currents marked on the top there. What's that? 0.18 to 0.2 milliamps, 0.4 to 0.8, 1 to 2, 3 to 5 and 4 to 10. So it's got these currents marked on top, and what they actually relate to is there's some test points on the board, some links. Let me turn it over, see if I can see some. So for example, there's one of the test points there. So what you've got to do is you've got to get your amp meter on the milliamps range, and you just got to put the probes between them two and see if the currents or anything like what is predicted, and that's going to give us an idea if the radio is working or not. Or, yeah, that's the idea anyway. So we've got that to do, and then it's time to start the alignment procedure and, well, I guess just basically see if it works. I'm sure we're going to do that next. And we are, but that isn't going to be today, unfortunately. So I'm going to leave you on a bit of a cliffhanger. Not it's about as excited as it gets on this channel, let's face it. Until next time, it's been great having you here. I've really enjoyed you being at the bench with me. Hope to see you again very soon, but until next time, that'll do. Bye-bye for now.